We are discussing the IIT-JAM 2019 Modern Physics problem. Here we have 1 marks MCQ. This problem is related to nuclear physics, and in this question, let us read it. In the thermal neutron induced fission of uranium-235, the distribution of relative number of observed fission fragment yield versus mass number A is given by. So, solution. We have to identify the correct yield versus mass curve. There are few points which has to be remembered regarding this. First point is yield curve for spontaneous or thermal induced curve is always asymmetric. And their contribution for symmetric point is flat. Second, this curve is obtained by fitting experimental data, incorporating delayed emission for neutron fission of thorium-32, uranium-232, uranium-233, uranium-235 and plutonium. Here we have to remove this uranium-232 not. It's uranium-233, 235, uranium-238 and Pu-239. For this, the correct option is option A, yield curve. This is a standard curve which is available in any of the book. You can refer it. Yield versus mass number curve. Mass number A. So correct option from the given plot is option A. For a quantum particle confined inside a box of side L, the ground state energy is given by E0, the energy of first excited stage. the energy of a particle inside a cubical box of side L is given by E nx and y and z equals to pi square h square by 2 ml square nx square plus ny square plus nz square. For ground state, nx equals to ny equals to nz is equals to 1. So E11 is equals to pi square h square by 2 ml square 1 square plus 1 square equals to 3 pi square h square by 2 ml square, which is equals to E0. For first excited state, nx equals to 2, ny equals to 1, and z equals to 1. So energy E21 would be pi square h square by 2 ml square 2 square plus 1 square plus 1 square is equals to 6 pi square h square by 2 ml square, which can be written as 2E0. So our option is A, 2E0. This question is related with the relativity. In this question, the amount of work done to increase the speed of electron from c/3 to 2c/3 is. We have to determine what amount of work needs to be done for increase this velocity. Increase this speed. We know that work done is equal to the change in kinetic energy. So, the work done in increasing the speed from V1 is equals to c/3 to V2 is equals to 2c/3 is given by W is equals to m0 c square 1 minus V2 by c square minus m0 c square minus m0 c square divided by 1 minus V1 square by c square minus m0 c square. Substituting this value, we got W is equals to 143.58 kilo electron volt. So this value m0 c square would cancel out. We would be having it here. I can write that m0 c square can be taken as common 1 minus V2 square by c square minus 1 minus V1 square by c square. So by substituting this value, we get this result. This problem is related with the Compton effect. A gamma ray photon emitted from cesium-137 source collide with an electron at rest. If the Compton shift of the photon is 3.25 into 10 to the power minus 3. Then scattering angle is closest to, we have to determine scattering angle theta. So from Compton scattering, we have lambda dash is equals to lambda plus h by mc 1 minus cos theta. Delta lambda is equals to lambda dash minus lambda is equals to h by mc 1 minus cos theta. Further, or cos theta can be written as delta lambda by h into mc 1 minus, substituting this value, 1 minus 3.25 into 10 to the power minus 13. This is h, 6.6 into 10 to the power minus 34. 9.1 into 10 to the power minus 31 into 3 into 10 to the power 8 is equals to 1 minus. So this, after solving it, we would get 0.866 is equals to root 3 by 2, implies theta is equals to 30 degree. So our answer is option C. This is an MSQ problem. Here the relation between nuclear radius and mass number A is given by R equals to 1.2, A at mass number to the power 1 by 2 fermion, implies that. So which of the options are correct, we have to find. Let us calculate first volume energy. So solution, volume of nucleus is given by E is equals to 4 by 3 pi r cube, which can be written as 4 by 3 pi r naught cube A, implies volume per energy is equals to 4 by 3 pi r naught cube, which is constant. So option B is correct. Now density of nucleus is given by rho is equals to m by v, which is written as m into A into 4 by 3 pi r naught cube into A, which can be written as, here m represents average mass of nucleon. Mass of nucleus is m into A, so that is mn. So m here A would cancel, so we would be having m to 4 by 3 pi r naught cube, which is again constant. That means our option A is correct. Nuclear force, attractive part of nuclear force has a short range, and nuclear force is charge independent. So thus option A and B are correct. an atomic nucleus X with half-life Tx decays to nucleus Y which has a half-life Ty. The condition for secular equilibrium is. Solution. There are two types of equilibrium. First is radioactive equilibrium, that is, it exists when a radioactive nuclide is decaying at the same rate at which it is being produced. The condition for this is lambda 1 n1 is equals to lambda 2 n2. Second is secular equilibrium. It exists when the parent nuclei has an extremely long half-life. Secular equilibrium is typical for natural radioactive series. Such as thorium and uranium. So, for natural series, we would be having secular equilibrium, and for radioactive series, we would be having radioactive equilibrium. So, the condition for secular equilibrium is parent nuclei has much larger half-life, which is given in option D. Thus, option D is our correct answer for this problem. In a typical human body, the amount of radioactive 40K is 3.24 to 10 की power minus 5% of its mass. The activity due to potassium 40 in a human body of mass 70 kg is in terms of globular, where half-life of potassium is 3.942 into 10 की power 16 second and Avogadro number is 6.022 to 10 की power 23 mole per second. Solution. Radioactivity is defined as R is equals to dn by d lambda is equals to n lambda. Lambda is half-life, n is the number of nuclei. Now n would be given by mass into Na divided by atomic mass or molar mass, ठीक है, Ma, which is equals to 3.24 into 10 की power minus 5 divided by 100 into 70 into 10 की power 3 to 6.023 10 की power 23 divided by 40. Activity is given by R is equals to 0.693 divided by 3.942 into 10 की power 16 into 3.24 per minus 5 divided by 100 into 70 10 की power 3 into 6.023 to 10 की power 23 divided by 40 would give us 6.0 kilo BQ. So our answer for this problem would be 6.0. The wavelength of K alpha to X-ray line of element is 1.544. Then the atomic number of the element is. Solution. This problem is related to Moseley law. According to Moseley law, we have mu is equals to 3 by 4 R infinity C into Z minus 1 square. This can be written as C by lambda equals to 3 R infinity C by Z minus 1. C से C cancel होगा. Here it would show Z minus 1 square would be 3 by 4. 4 by 3 R infinity lambda. Substituting this value 4, 3, 1.09, 10 की power 7 into 1.544, 10 की power minus 10 is turning out to be 792.14. So Z minus 1 would turn out to be 28.14 or Z is equals to 29. So the atomic number of that element would be 29. A proton is confined within a nucleus of size 10 to the power minus 13 cm. The uncertainty in its velocity is into 10 to the power 8 meter per second. Solution. According to Heisenberg Uncertainty principle, del P del X is equals to H cross by 2 implies M del V to del X is equals to H by 4 pi or delta V is equals to H by 4 pi M del X, that is 6.6 into 10 to the power minus 34 divided by 4 into 3.14 into 10 to the power. Mass of proton is 1.672 10 to the power minus 27 and delta X is 10 to the power minus 15 meter. You can check it out. Here it is centimeter. I have taken 10 to the power minus 15 meter. So a joule per second. Calculating it, we will get 0.31 into 10 की power 8 meter per second. That is 0.31. So our answer is 0.31. Given the wave function of a particle is psi x root 2 by L sin pi x by L, 0xL and 0 otherwise. So probability of finding the particle between x is equals to 1 0 L by 2 is. Solution. This problem can be solved qualitatively. That is a box of length Lg. The probability of the particle in finding the complete box is 1. So if we have to find out in the half of the region, then probability would be half. That is 0.5. So our answer would be 0.5. We can also use it from formula. Using formula, of finding particle in region x L by 2 0 is given by P 0 x L by 2 is equals to 2 by L 0 to L by 2 sin square pi x by L dx. This term would be equals to 1 by 2, that is 0.5.